I'm back on the Sansui 500A. I looked at this one a few months ago and determined that we needed to change a whole handful of capacitors in it because it was red plating the output tubes. We'll do a little bit of a look back on the first one just to take a look at the symptom, and then we're going to go in and we're going to change the parts out now that the parts are here and get this thing sounding like it should. Let's check it out. All right, today is the day I'm sure a few have been waiting for. I've got this old Sansui vacuum tube receiver here, model 500A. We went over this before. It needs capacitors. And capacitors, I have. I had to go and buy a bunch of parts. I think I got them all. I'm pretty sure I got all the ones I need to replace. I don't think I got the big ones for the back. But I did get a handful of caps. This cost me like $65 just for that, and all these little plastic bags that they come in, and they couldn't even give me a paper bag to carry it home, and I had to supply an old bag to carry it home because they wanted to charge me 40 cents for a bag. Ridiculous, you know. We got all these little plastic bags, but if you want the paper bag to carry it home in, you got to pay for it. Where's the logic there? Anyway. Let's get this thing open. I'll start changing out caps. We'll see how good we can make this unit sound. Before we get into actually repairing this one though, we're going to take a look back at the initial inspection and look at the fault. The receiver is broken down into two stages. This is the tuner section, the radio section, and the power amplifier is over here. It's a push-pull design, and this unit here would produce approximately 15 watts per channel. So it's not a particularly high power unit. The 1000, I believe it did around 30 watts per channel. But this is the lower power version. 15 to 20 watts is all you're going to expect to get from these tubes here. And of course the tubes on this one are 7189A tubes. Vacuum tube stuff is one of the things that makes me a little nervous. That's why I don't have a watch on now. We'll just check for some voltages here and see whether we've got any voltages. 179 volts, 145 volts. So we know that the power supplies, the B pluses, are there. 111. So we got power. That's a good sound. I guess I could plug my, why don't I plug my MP3 player or something into the auxiliary input, and we'll see if the amplifier part works. Okay, I've got my auxiliary plugged in. These controls are really dirty. Now it's not going to sound great because we're running at low voltage. If I flip the full power, because I think we're okay. Those controls need to be cleaned for starters. So let's deal with the switches first and the controls. Let's get some cleaner into the volume control. Top cover comes off to clean the input switch. Turn on the power again, and we'll clean the controls, these switches, once everything warms up. Yeah, the outputs. That shouldn't have started humming like that. That's why I cut the power off right away. Something else is up with this unit. I noticed a little bit of red plating on this tube here. We may have a coupling cap that's going bad. That's why I cut it off so quick, and I put it back onto the dim bulb tester just to keep the current down when it hummed there. We probably have we could have a bad plating or bad blocking cap on this side, or the tube itself could have a problem. But first things first of all, I'll swap the tube over. I'll swap these two tubes around and see whether I get the same effect on here. Of course, monitoring it very, very carefully.
But I think we're probably going to have to change out some of the blocking caps in here that are probably going a bit leaky. Again, that's to be expected. The amplifier's working. I did get that hum. That's probably what popped the fuse, was because tube went into overconduction. And you want to stop that right away, because if you let that continue, not only can you burn out your tubes, but you can also burn out the transformer. But the tube itself may have an internal short in it, and that's what I'm going to do. I'm going to swap them around and see whether the fault stays on this tube here, or whether the fault goes to this other one. As you can see, these tubes here do have lots of hours on them. You can see just right through here, the black that's showing up here, that's just from the tube itself in operation. They are long in the tooth, these tubes. They look like they might be originals. They're NEC. So these may have been original tubes in this unit. So I'm just letting this warm up again. I'm going to look to see if anything starts to glow red, the plate on the tubes. I don't even need to put sound through it for this. Oh, this one's starting to go. This one's starting to get red here. So I just cut it down there. Yeah, this one's starting to go bad, or starting to heat up. So we have a bias problem, and this tube has been driven into over bias. So let's flip her over and take a look underneath here. So what typically causes red plating of your output tubes, especially if it's only one, is that one of these blocking capacitors, I believe that's this one here, 0.3 microfarad at 350 volts. There's 4 of them, one for each of the output tubes. There's one, that's for the tube that was actually getting warm, so this is likely the one that's gone leaky. The other one is this one here for this tube, and then you've got another one up here for this tube and another one up here for this tube. And these will all be changed, like all these are going to be changed out. I do believe I forgot these ones. I ordered all the other ones, I did not order these ones in. I think these caps are probably okay anyway. It's mostly just the paper ones, metallized paper, and that's 4 caps, 4 plastic bags. I thought we were supposed to be trying to reduce plastic bag usage. That's for these 4 caps here. These are these 0.3. I've got 0.33s at 630 volts. The originals were at 350, but that's what I could get. So we're going to change these ones first. These are the bypass capacitors. They are metallized. The originals were metallized paper. And these ones here, if not replaced, this can cause the red plating of the output tube. So these are a must to replace these ones. So we're going to get these ones done first. And they're point-to-point wiring, so it shouldn't be too hard to get in here, but some of the leads may not be quite long enough, so I might be just cutting them fairly short and just splicing them right in to the existing lead rather than go all the way back. Just depending on the length. Like this one, I can probably put this one here, but the other side might not be quite long enough to make it down to this tube socket. I'll start out with this one at the top here. I'm just going to actually cut the part out here, and then we'll remove the wires after and get the insulation material off. Get that onto the new lead. Okay, I'm going to put this one right up to where the old one went.
That's one down. We got the next one over here, and that goes over to this other piece that cut off up here. That was a bare lead on that one. This one's got a covering on it, but this other one didn't. I'm not going to obviously film the entire process, so I'm just going to leave the camera running here for a couple minutes as I do a few of them, and then a lot of this will be done off camera because I'm going to be here for a while. We'll just turn the camera on and off as I'm working, just so you guys can see the progress I'm making. Remember, this unit has not been powered up for a few months, so there's no chance of any of these capacitors holding a charge after this time. But if I had just recently unplugged it, I would be a little bit more careful in there, because these can hold a bit of a charge for a while, and they can bite pretty good. One thing that's important is you get a good physical connection before you solder it down. So you squeeze it on with pliers and bend it around the end of the tube socket here so that I can get a good solid mechanical connection first, and then the solder will hold it in place, prevent it from coming off. Okay, so I've got the 4 main coupling caps replaced here. We're going to do this one next. 40 microfarad 300 volts. I had to get the 47 at 400 volts. As you can see, it's a lot smaller, but it'll fit in here. We're going to have to probably just tie it down to the leads, because I don't think this one, well, I don't think this is going to reach. I don't think the leads are going to be quite long enough to reach where it needs to, so we're going to have to just cut and twist on this one. Do it one lead at a time to make sure we don't mess up the polarity, because nothing here is marked. So we'll just twist the wires together and solder them on. Do a good mechanical connection first. And I can shorten this a little bit. It doesn't need to be that long. I can cut this back a bit like that. And then this side almost reach. But we'll twist it as well, just to make sure that there's enough wire. I saw something interesting today on the news, and maybe why it's not a wise decision to buy a used Tesla. So a car dealer, I guess it was buying and selling vehicles, sold a Tesla, and the guy comes back because the Tesla won't charge at the charging station, and back and forth. This is on YouTube if you want to look this up, but the guy spends time on the phone with Tesla and he records the conversation with them, and they basically said, well, the car was salvage title, so whether it was an accident or whatever, had been written off, but it hadn't been written off because the insurance title was not salvage. That's why the story gets, the plot thickens a bit. The insurance title was not salvage, but Tesla's title was salvage, because of course you've got a car that reports back it phones home basically every time you turn it on, and it phoned home and said that it had detected damage from impact or whatever, and therefore it disables the fast charging, the supercharging, and you have to have it inspected by Tesla. And of course there's all kinds of money involved with that, and if they say, well, we got to replace the main battery pack, well, that's it, you're screwed. And I found it was interesting that the guy that sold the thing, I guess, sold the car, he's going to be the one that got scammed. Someone traded in or sold him a car that had been that they knew. I'm sure they knew it was damaged, but they didn't tell him that. And of course, can't do his due diligence because Tesla won't give you access to the records. When the guy on the phone, he was trying to find out for them, when did this damage happen? You've got a record of it. When did the damage happen? Nope, they couldn't tell him that. So he's kind of stuck. I found that was interesting. That might be a reason to never buy a Tesla. Not that I would ever buy one anyway, because I don't like Elon Musk and everything he stands for. But that would be another reason to not buy one right there. Okay, let's move on to the next one here. I've got a couple small ones up here to do. We'll look for whatever pops out of the bag and do the next one, the next value I find. Okay, I've done the 1 microfarad and the whatever these ones were, 0.3. Got a couple 30 microfarad 6 volt. These are little electrolytic caps. They parallel a resistor. I got some 33s here at 50 volts. Originals were 6, I should say. They were okay going with 50s. These are polarity sensitive, so positive to the tube. And we're just going to parallel these ones. They're radial as opposed to axial leads. We'll just parallel the resistor just like that. Just wrap it around here. Get it out of the way. I'm going to be doing the same to my old Macintosh at some point. It's a work in progress, right? I got an old Macintosh. I've showed you guys it before up in my storage unit. I haven't used it in years, but it's going to need a recap for sure, and it'll be something that'll be on the agenda at some point. Yes, I have a Macintosh that I don't use. Basically, the reason I don't use it is because my Yachin sounds better. I know people might find that hard to believe, but the reason for it is because all these old tube amplifiers use carbon resistors. And the problem with carbon resistors is that, well, they have quite a high tolerance, 10%, 20%. These are 10% with the silver band, which means that, say, a 100 ohm resistor could be 90 ohms to 110. The problem with them is, as the temperature changes, so does the resistance. It can change on them. It can change a fair bit, and that changes the sound. Whereas the modern tube amps that use thin film resistors don't have that issue with them warming up and the sound changing. And that's really the reason why I'm not using my Mac. Also the fact that I don't want to burn up the tubes any faster, because they're unobtainium, some of them, right? They are obsolete numbers. And yes, you can sub them, but once you put sub parts in, then it's now no longer original. I kind of want to keep the original status with the original tubes, because they're all marked Macintosh, right? So I don't want to burn them up, and that's why I have not been using it. I'm making progress, swapping out a lot of these old oil caps for new modern capacitors. Film caps, which will be a lot more reliable than these old oil caps. As I mentioned before, not every single cap is going to get replaced in this. I'm only doing the ones that are actually critical to tube life. And we'll see how it sounds then, because I mean, you could go crazy. You start changing every single one of these caps, and it's going to get real expensive, because some of these caps, like these little ones here, are like $8 a piece for these ones. Some of these high voltage caps are actually quite expensive compared to the run-of-the-mill low voltage caps. And they've certainly gone up in price since the last time I bought some, that's for sure. Just get a couple more to do of these oil-filled caps. At least we still have one local component suppliers in Vancouver that I can actually go in and pick parts up, which is good. You know, we used to have a bunch, but we're down to one now, and I hope that he stays in business for a while. I support the local business because I want him to be here, right? That's why I don't order stuff online. I don't order parts online. Besides the fact I don't want to pay shipping charges and broker fees to bring them in from the States. But I'll pay a little more for the parts locally, but if that helps keep the business around, then I'm all for that, because we really do need our local parts guy. I want to see him stay in business for as long as possible. And how busy his shop is, I'm sure he probably will be, because there's always a crowd in there whenever I go in. It's funny to see, a huge cap that was in there before being replaced by a very small physical cap. That's just progress, right? We don't need the physical space that the old ones needed. As long as the voltage and the capacity is the same, then we are good to go. This is, I think, the last one. This is a 25 microfarad at 50. We'll change it out and put a 33 at 50 in place of it. And then I think it's ready to test. This will have all. Whoops! This should have all the critical caps changed, the smaller ones. I haven't done the big multi-part caps, multi-piece caps on the top here. I didn't get them. They did not have stock, but they also are not as critical. I mean, if they go bad, you typically get a humming sound, right? They're not going to blow your tubes out. The coupling caps are the ones that are the most important, because they go electrically leaky, and once that happens, your tube can go into overbias and red plate. I'm going to power it up, plugged into the dim bulb. That'll let things charge up slowly. The bulb will get dimmer as the tubes come up to temperature and the power supply charges up and so forth. Alright, this thing's been cooking for a bit. I'll flip it to full power. And we see it got piping sound. coming off my radio tuner that I've got tuned to my little test transmitter that's on the other side of the shop. Sounding pretty good. Let's switch over to the auxiliary input coming off the MP3 player. And we gotta make sure that that tube's not red plating. It was before. If you remember the first one, we had outputs that were red plating. That was due to leakage on the coupling caps, which have now been replaced. No more red plating. This thing's sounding great. I don't think I really need to do any more to this because the main filter caps are obviously fine. There's no hum or anything. Wondering how many caps were changed on this. Well, I got them all banged up here. Let's go over how many caps I actually changed on this thing. There was a lot. There was a lot. I'll tell you that much. We'll line them all up here. We changed a few. I've been on this thing for a few hours, but as you can see, yeah, there was a bunch. These all had to go. Every one of these. Oh, I just dropped one. Anyway, one rolling around on the floor here now, but these all had to go. It was 23 capacitors I changed on this. Yes, more could have been changed. I didn't change every single one of them, but I changed all the ones that needed to be changed. I did not change the electrolytics, the multi-part electrolytics. I did not change some of the electrolytics on the solid state circuitry that's part of the tuner, because there is some solid state on here. I only changed the high voltage caps that were critical to the tube's performance and tube life, because these are the ones that are going to cause your tubes to red plate. In the case on this one, it was these ones here, these metallized paper 0.3 microfarad. These were the ones that were causing the output tubes to red plate. 4 of those were changed, but we did them all. This thing's sounding good now. If you've got this vintage gear with these old paper type and really old electrolytic caps in them, they really do need to go. This is from 1/10/1966, so January 10th, 1966 is when this one was made. These all gotta go, these old ones. All right, I'm gonna throw this back together now and give the owner of this one a call. He'll be happy to get it back, and I'll be happy to get it out of here because this thing weighs a ton, as you can imagine, with the big iron in there. Okay, we're gonna test the radio out on it now, FM, and we'll go through AM as well. I'll turn the plasma off of it, obviously, for AM. But here's FM. I don't have much of an antenna either.
Expensive. What's expensive? expensive is paying for heating and cooling.
Is that plasma interfering with
high efficiency
FM?
upgrades will use less energy.
We'll turn
which
that
will help
off.
reduce
It's interfering with the
overall greenhouse gas
FM.
emissions. Plus, rebates to discover all our rebates to help conserve cooperative.
On Willingdon and Camden Way, Surrey and other crafts there southbound.
AM. Not much on AM.
This is CHNB, AM 1320, Vancouver.
The AM band is getting pretty sparse around here.
Let's say a 3-year-old has died in a tragic crash. They were struck at the intersection of Vedder and Petawawa.
CKNW on your favorite.
That station's changed frequency. Looks like their power is down now. Because they've gone from 980 down to 730. And
with a weapon. In this case, it's quite troubling because this was found dead 4 years ago. Her husband, Ian Hunt, was scheduled to appear in court this morning on a charge of indignity to human remains.
Working together with...
Okay, everything's working. And then the auxiliary input. I'm going to say this is a success. We'll turn it off and get it back together and get it back to the owner of it. Thanks for watching. We'll catch you in the next one. Bye.